Hey everyone, today we're going to be talking about an interesting algorithm. It's called the logistic regression. It's one of the most basic algorithms in the whole machine learning, so we're going to touch it and we're going to understand how it works. So firstly, we are going to state our problem. What do we have in inputs, what do we have in outputs, what is the goal of it? So firstly, we have the x. It's just a matrix of the data of objects and the values of the features. It's a d-dimensional matrix. Then we have an output. Logistic regression is basically a classification algorithm, so we have to classify every object between 1 or 0, so it's either 1 or 0. Our goal is to create a model that estimates the probability of the output being 1, being the first class, out of like in the face of the axis. I'm sorry, should have been in the uppercase. We're gonna introduce what is Z and how the model actually works, because as you may have noticed, this is our logistic regression model. This is what we're gonna be talking about. Those dots are with class 1, as you may see, and those are with the class 0, as you also may see. So let's firstly use this thing. It's a basic thing for all linear family models, because we need to actually say the weight of each feature, because without it we wouldn't be able to understand how each feature affects the data. Is it important, or is it actually not important? If it's not important, we can get rid of it. So it's an important thing. So let's say that Z equals this thing. But obviously we cannot use just linear regression, because this, as you may remember, I hope you do, this is the formula for linear regression. So it would give us a straight line. But we cannot fit a straight line here, because obviously it would not represent what we need to represent. So we need to take it to a more interesting function. It's called the sigmoid function. As you may see, here's the formula. Here's the formula broken down. And firstly, you may not understand how it works, but it's such a beautiful thing, to be honest. So firstly, let's say that this function without x theta, just with x, it looks like that. And the main thing that we're gonna talk about is this moment. So the sigmoid function actually gives us an estimation of the data by adjusting x. This sigmoid would be shrinking and expanding. So, and it would, just as in linear regression, fit with data values, because if 1 is 0, let's say like that, so have x2, and with x2, let's say you have a probability of a feature being 1, like 0.8, for example. But when the x theta is 0, so we don't exactly know, we would probably give something random, and so on. So here we're gonna assign it to class 0. Here we're gonna assign it to class actually 1. Let's then see how we fit the model, because we cannot use the matrix thing with linear regression, because we're gonna be talking about the fitting the cost function, and the cost function actually says that here's the cost function. I'm gonna explain it, but firstly, you may notice that it's a transcendentic equation. We cannot just solve it with algebra as we did with linear regression. So let's firstly introduce our log-loss method. Firstly, it may seem complicated, but in reality it's not, because you may understand that y is actually either 1 or 0. So if y is 0, we would probably get 0 here, so this whole thing would be 1, and this whole thing would be multiplied by, powered by 1, so it's just 1 minus probability function, as I let you see, or if the y is 1, so we're gonna take this thing and not gonna take this thing. and this is a probability. So it's obvious that by multiplying all of the probabilities we want to maximize the value. But for a computer it's extremely complicated to multiply like millions or hundreds of hundreds of thousands objects with their own probabilities, which is always 0 point something, let's be honest. And it would give us a very little number, which our computer would probably say it's 0. But we should not do that, and we have a decent function from algebra. It's a function, to be honest. It's logarithm. So let's take a logarithm of all of this thing. And as we know from calculus, the product of all of those values would be the sum of them if we take the log clause. This L, it's log L. Now we just say it as mathematical L, and it's lowercase y times log p by theta, and it's eth example with the same thing. So, and we're gonna maximize it. How do we maximize it? We maximize it by the gradient ascent. It's not the gradient descent because we're actually ascending. So here's the basic thing again. We have the gradient and we are just ascending, not descending. And I think it's understandable as we understand how gradient descent works. So, and by the end of the fitting process, we would get something like that, and we would be able to give it some values, and it would show us which class we're lying to. So that's everything. Write in comments what I should adjust and what was better, what was wrong, what was not understandable. I hope everything was understandable. So thanks, y'all. I hope you will be in the next video.